Hello students. So today we will discuss about dimension and dimension analysis. So dimension and dimension analysis. So the physical quantities we write physical quantities in terms of base units, like physical quantities, the base units, for example length, we write L. Okay, for dimension analysis we write these units in brackets, right? Like L, mass, M, and time we use T, and likewise. Okay, so these are the base units, example of base units. And if you want to write derived units, so for example velocity has units length divided by time, so it will have length divided by time. So in a single linear fashion you can write it L t to the power minus 1. Okay, so after that we have dimensional consistency. So all the equations should have dimensional consistency. Dimensional consistency बहुत जरूरी है बच्चों. जैसे कोई भी फॉर्मूला है, फॉर एग्जाम्पल लॉज ऑफ मोशन है, जैसे v इक्वल टू u प्लस at. वेलोसिटी की इक्वेशन है where v is the final velocity and u is the initial velocity, a acceleration and t is time. So all these entities should have dimensional consistency. If it is had dimension of Lt to the power minus 1, okay, Lt to the power minus velocity, so u will also have the same units, Lt to the power minus 1. And this term, all these terms will have same dimensions. So Lt to the power minus 1, and this also should have the same dimension. So we will see A. A is the unit of velocity per unit time. So change in velocity with respect to time. So velocity, unit of velocity is Lt to the power minus 1 upon time multiplied by t multiplied by time. So you can cancel out. So what is left here is Lt to the power minus 1. So we will see one more example. एक और example करके हम देखते हैं बेटे. जैसे for example the second law is y is equal to u t plus half a t square. For example, this is the equation. So all these terms should have certain level of dimensional consistency. So see, y is the length or distance traveled, right? So it will have unit L. So all the terms should have unit dimension L. Okay. So let us check. So ut will have L t to the power minus 1 multiplied by time. Okay, plus half is dimensionless, so multiplied by L t to the power minus 1. This is the velocity upon time, right? So you will have velocity upon time multiplied by t square. Time का square है ना, तो you have to write t square here. So now t to the power 1, if you multiply, okay, so these will add up. Okay, so at t to the power minus 1 plus 1, so it will be, this will cancel out, only L will left here. So it is consistent here. नाउ वी विल चेक दिस टर्म. सो t 1 पावर कैंसिल होगा और इससे -1 t ये कैंसिल आउट हो जाएगा. सो वी विल लेफ्ट विद l. So L. So in this way we see all the formulas. Make sure that they should be dimensionally consistent. Okay. So the next thing comes is you can deduce any formula you can deduce using this method, dimensional analysis method. How? For example, we will see the example of time period of a simple pendulum. So the time period of a pendulum is directly proportional to, if it is given to you, it is proportional to length of the pendulum and the acceleration due to gravity. Okay, so the g. So now, if we remove the proportionality sign, the t can be written as some constant k into L into g, where g is the acceleration and L is the length of the pendulum. Okay. So this is the pendulum. Okay. It is hanging and it is continuously moving like that. So time period of oscillation is proportional to length and the gravitational acceleration. Now, using dimensional analysis method, we can deduce a formula for this. How? Now let us compare the dimensions. So t is having the dimension only t, simple. And this is constant, so it is dimensionless. L, okay, L will have a dimension of L, and G, we know that G is the acceleration. Acceleration has the unit of, acceleration will have unit of velocity upon time. So we have written earlier, हमने पहले देखा था कि velocity is the length upon time. So it has unit of L upon t, LT minus 1 upon t. Okay, so it will have unit of LT to the power minus 2. Okay. LT to the power minus, right? Now we will compare the the powers. Okay, we will compare the powers. For example, let us compare the power of t. Okay, so before that you have to write some. Let's suppose the t is the t is let some power of alpha and it is some power of beta. Okay, we don't know initially that we don't know that how much it is proportional to which order. Okay. Order we don't know, so we will write here alpha and let's suppose beta. It is proportional to some power of alpha and beta. Okay, we just have to write this. Okay, so we can alpha and beta accordingly. Okay, alpha and beta you have to write. So now if you compare equation L to the power a alpha, so इसकी power alpha बेटा alpha and इसकी power यहाँ पर plus बीटा, अल्फा प्लस बीटा. अब देखिए L इधर L की पावर बेटे कुछ नहीं है ना, यहाँ पे L की पावर 0 है. L की पावर 0 है, so अल्फा प्लस बीटा will give you 0. Okay, and now we'll compare the power of t. Okay, so यहाँ पे t का टर्म में 1 है. ठीक है, तो t के टर्म यहाँ पे 1 है लेफ्ट हैंड साइड में. राइट हैंड साइड में आपको t के पावर्स कंपेयर करनी है. तो t की पावर्स बेटे ये देखो क्या है, यहाँ पे L में यहाँ पे पावर कुछ नहीं है, अल्फा में कोई पावर नहीं है. बीटा में इसमें देखिए t की पावर -2 है, तो -2 टाइम्स बीटा हो जाएगा, -2 टाइम्स बीटा, राइट. और यहाँ पे 1 है, सो इट विल बी इक्वल टू 1. सो बीटा हम निकाल सकते हैं बेटे इसमें से, बीटा इज इक्वल टू 1/2 -1/2. So if we know the beta value of beta minus 1 by 2, we can find the value of alpha. So alpha value will be equal to alpha minus 1 by 2 is equal to 0, alpha will be equal to 1 by 2. So in this way we have seen that you have found alpha and beta. Now you can put this equation into equation number 1. Okay, value of alpha and beta. So in this way we got our formula. ठीक है, हमें अपना फॉर्मूला मिल गया t इज इक्वल टू k मल्टीप्लाइड बाई l की पावर हाफ इंटू g की पावर माइनस ऑफ हाफ, राइट? और यू कैन डायरेक्टली राइट इट k अंडर रूट l अपॉन g. So this is the formula for time period of simple pendulum oscillation. Okay? So this is all about dimension analysis. Thank you, students.